A group of skiers start out at the bottom of a mountain, here represented by the letter A. In order to get to the top of the mountain so they can ski back down, they have to use a chairlift. From the bottom of the mountain, they go from station A to station B, represented in red. From station B, they move to station C, green. Station C to station D is orange, and from station D to E is blue. Of these four paths, which one is the steepest? Which one is the slantiest? Which one would be the hardest to climb up without help? We think about steepness and slantiness all the time, maybe in terms of stairways or in terms of hills, but how do we measure that mathematically? In order to measure steepness mathematically, we are going to use a simple ratio formula. We are going to measure how far up you climb and how far across it takes you to reach that peak. So to go from A to B, the red path, we have to climb 1, 2, 30, 40 feet. So we have gone up by 40. That's going to be our numerator. Our denominator is going to be how long horizontally it took us to get there. Starting from A, to get to the peak, we go over 1, 2, 20 feet. So our ratio is 40 over 20. This looks like a fraction, and fractions can be simplified. 40 over 20 simplifies to 2. How about our green path to go from B to C? We go up 10, that'll be our numerator, and getting there takes us 10, 20, 30 feet. So we rise 10 feet over the course of 30 feet. This simplifies to 1/3. Our orange path goes up 10, 20, 30, 40 feet, just like our first path did, but it requires 10, 20, 30 feet to get there. 40 over 30 can be simplified to 4 over 3, or if you want to make it a mixed number, 1 and 1/3. What about our blue path? Just like our second path, we go up by 10, but this time it takes us a fairly gentle 10, 20, 30, 40, 50 feet to rise those 10 feet. 10 over 50 becomes 1 over 5. Whichever one of these values has the greatest absolute value, that is farthest away from 0, is our slantiest slope. 1/3 is bigger than 1/5. 4/3 is bigger than 1/3, but 2 is the biggest of all four, meaning our red path from A to B with a slope of 2 is our slantiest, steepest path. This measurement is referred to as slope mathematically, and it is measured as the change in vertical position, in other words, how your y changes, divided by the change in horizontal position, how your x changes. Sometimes this is referred to as rise over run. Let's look at this in a more textbook arrangement. Here is a Cartesian graph with 2 points on it. If we want to use the same system we used for the skiers, all we need to do is look at how far we go up and then divide that by how far we go over, rise over run. So starting at our orange position, we go up 1, 2, that becomes our numerator, and we go over 1, that becomes our denominator. 2 over 1, of course, simplifies to 2. But what if we wanted to do this mathematically, instead of this count up and count over system? What if we want to use the formula? We are going to take the two y values and subtract them, put that on top, and then on the bottom, as our denominator, use our two x values. They're color-coded in this example to make it easier to understand which is which. Our orange spot is at 1, 3. Our green dot is at 2, 5. 5 is going to go into the y2 position. It is the y coordinate of the second point. 3 is our y1. It is the y coordinate of the first point. 2 goes into the x2 position. It is the x of the second point. And 1 will be our x1, the x coordinate of the first point. Plug those into our formula, and we have 5 minus 3 on top and 2 minus 1 on the bottom. 5 minus 3 is 2. 2 minus 1 is 1. You'll notice that 2 over 1 is the same as we got from our counting system over here. And 2 over 1, of course, simplifies to 2. Now, the thing about slope is that any line only has one value of slope. It doesn't matter what 2 points you choose on the line, you will get the same slope every time. This is the same line, but I've chosen 2 different points. Now, our orange point is at -3, -5, and our green point is at 0, 1. 1 will become our y2. It's the y coordinate of the second point. -5 is our y1. x2 is 0. And x1 is -3. Plug those into our formula and you get 1 minus -5 and 0 minus -3. Notice that we have both the minus sign and the negative symbol. You need both of them to make the formula work. 1 minus -5 is the same as 1 plus 5. Oops, it's a little slanty, but it looks like a plus sign. And 0 minus -3 is the same as 0 plus 3. So we get 6 over 3, which of course simplifies 6 divided by 3 to 2. The same result we got when the previous pair of points on the same line. Here's a different example. Notice this time it's running downhill. Our orange point is at -2, +4. Those will represent our x1 and y1 values. The green point is at 1, -5. Those will be our x2 and y2 values. Let's plug in the information we know. y2 is -5. Put in your minus sign. y1 is 4. So the top will be -5 minus 4. x2 is +1. Put in our minus sign. x1 is -2. The negative symbol needs to be there. All right. -5 minus 4 across the top gives us 9. And 1 minus -2 is the same as 1 plus 2, which is 3. Forgot to add the negative sign there on the top. -5 take away 4 is -9. Now we can simplify. What is -9 divided by +3? A negative divided by a positive is always going to give us a negative answer. And then 9 divided by 3 is, of course, 3. Remember the previous line that we did 2 examples for? It was running uphill this way. And remember it had a positive slope? This example has a negative slope, and it is running downhill. This is an important distinction to remember. The red arrow in this example is running uphill. Therefore, it has a positive slope value. The blue arrow is running downhill. Anything that runs downhill has a negative slope. Let's do a few more examples. Here we have 1, 3 and 2, 7. First and foremost, are we going to have a positive or a negative slope? This line is running uphill. Therefore, the answer is going to be positive. Let's plug in our values. y2 is going to be 7 minus y1 is going to be 3. x2 is 2 minus, that's meant to be a minus sign, ignore this little bit here, x1 is 1. 7 minus 3 gives us 4. 2 minus 1 gives us 1. That gives us a ratio of 4 over 1, which simplifies to positive 4. This line is running downhill, which means it's going to have a negative slope. Our green spot is at 2, 2. The orange spot is at negative 2, 4. Let's fill in the blanks of our formula. y2 is 2 minus y1 is 4. x2 is also 2. x1 is negative 2. 2 minus 4 is negative 2. And 2 plus 2, since subtracting a negative is the same thing as adding, gives us 4. We have negative 2 over 4. What can that be simplified to? Both of those values can be divided by 2. Negative 2 divided by 2 is negative 1. And 4 divided by 2 is 2. So our answer is a slope of negative 1/2. Notice that we have a negative slope, and the line runs downhill. There are two exceptions to this rule. What if the path runs straight across, or what if the path runs straight up and down? The red line is completely flat. It doesn't have any slantiness or steepness at all. Its slope value is 0. The opposite of this is if it runs straight up and down vertically. The blue line has an undefined slope, or an infinite slope. These are special cases you might run into here and there. Now, every example we've done so far involves a drawing. But what if you don't have a drawing? What if you are simply given the question, find the slope between 2, negative 3, and negative 4, positive 5? The trick is to assign one of those pairs to be your x1, y1, and the other to be your x2, y2, and then fill in the positions in the formula. Let's turn them green and orange, like we've been doing in our examples, and then pull up our formula and fill in the blanks. y2, the green y-coordinate, is going to be 5. y1, the orange y-coordinate, is going to be negative 3. x2 will be negative 4, and x1, the orange x-coordinate, will be positive 2. So these are our positions: 5 minus negative 3, and negative 4 minus 2. 5 minus negative 3 is the same as 5 plus 3, and negative 4 minus 2 is negative 6. So we get a ratio of 8 over negative 6. This can be simplified down to negative 4 over 3. The other option, if I give you 2 points but no drawing, is to create a drawing. Place the orange point at 2, negative 3. Place the green point at negative 4, 5. And then we can use the drawing method that we used originally. 1, 2, 3, 4, 5, 6, 7, 8. 8 up, and negative 1, negative 2, negative 3, negative 4, negative 5, negative 6 back. The same values we got from the formula, 8 over negative 6. You also know that this answer is going to be negative because to go from point to point, you have to run downhill. If it's downhill, the answer must be negative. And of course, negative 8 over negative 6 gives you the answer negative 4 over 3. Your homework is in your homework folder, and it is named 21st of September Slope Worksheet. It is due by tomorrow morning, and we will go over those answers first thing in tomorrow's class. Have a great rest of your day.